that better?
Much better.
Okay, I can see it there. Okay, well, my name's Dave Montoya from Los Alamos, and I'd like to catch up a little bit on one of the other ECP projects, which is focused on continuous integration software deployment at the facilities. Now, Todd went through a lot of the aspects of this project, so I hidden some of the slides. We've got a lot of time to talk, so please ask questions. We can discuss a little bit about what this whole project is and how it started. So to start with, I'd like to give a little context about the project. And Todd covered a little bit of this as far as how ECP is broken up and what the different aspects are of the ST projects versus the AD projects versus a hardware integration. And we sit in hardware integration, and a big aspect of it was trying to figure out, well, what's the integration between what's going on in ECP software technology projects and AD projects and what's happening at the facilities. And the facilities is where the large machines are actually going to go. So that's where the tie has to come into play. And there's basically, so it's basically structured as almost a facility project. Most of the team members actually belong at the facility. We've got a couple up here. We've got Mario and Tiffany from NERSC. We have also at each of the other laboratories across the DOE complex, both Office of Science and NNSA, there's approximately 2 people or so working on it, and we've got a small support team at New Mexico, at the New Mexico Consortium. We've got Paul and David up there. They're part of that team.
Technical difficulties. Click OK. Slide.
Oops. I'm not sure why that always happens. Okay. Is that still working?
Yeah. Yeah. This. Let me get rid of this. It gets in the way of your slide.
Oh, because it's taking over there.
Yeah.
Okay, so we're talking about a little bit of the context of the project. So the main focus has been to do 2 things. One is to bring continuous integration into play across ECP into the facilities, and then also look at software deployment. And if you look at continuous integration and you look historically and where this thing came from out of the ST projects, this has been happening across application teams and at facilities probably for the last 4 or 5 years. But it's been more of a grassroots level. People have been using Travis, they've been using Bitbucket. There's a lot of different things that are coming in, really causing a lot of headaches for the facilities that are running machines and have security constraints. They're starting to pull their hair out. So a few years ago, the ST projects actually started a little study where they actually went and talked to teams and they talked to facilities and what are the problems you're having? And they put together a set of requirements saying this is really what we need to do to kind of facilitate this whole process. And then part of the whole process, like Todd talked about, an ecosystem being developed, this is really a solid aspect of having that ecosystem actually work, to being able to test across multiple architectures, platforms, software environments, so that you could actually have a healthy ecosystem so that when products get deployed and are integrated, they're working all together. And so it also ties into the SDK issues and some of those strategies as well. So based on that, the idea was, well, let's try to put this process together. So part of that ended up being an RFP to have changes being put into some type of a continuous integration process and deploy them at the facilities. Now, another thing getting into the software deployment part, this is really also very difficult when it comes down to what happens at the facilities. They're having to take care of multiple machines and to support their application teams. There's a whole host of different compilers, MPIs, and combinatorial variations that make it really difficult to actually have new things come in and get deployed. So that's the other problem that this whole thing is trying to solve. So when you look at what happens at facilities, whether it's software deployment or being able to implement a continuous integration, there's a whole host of security issues that need to be kind of played out. It's hard to have things running persistently on HPC systems so that people can just attach to and run jobs on like you need for a continuous integration process. There's issues with trusting the code that you're bringing in, where it comes from, how it's vetted, how it comes into the environment. And then the whole idea that at the facilities, they want to know who's actually running code because they're using batch systems, they're allocating different parts of of the overall system, and they need to know who's actually getting on it. That's why in many cases in the HPC environments, you have, as a user, you get an entire node. You don't have multi-tenant capability because they want to know who's using that node and ensure that you got security across the applications and components that you're running. So what does our continuous integration environment look like? And this is a vision we came up with a couple of years ago when we first kicked it off, with the idea that we really wanted to be able to provide the capability for teams to test across all the labs or more, and on different systems that they may have, different environments, and be able to kind of put that whole ecosystem together. So a lot of the things that are needed had to do with enhancements to GitLab, and GitLab was what we chose when we put that RFP together. We chose GitLab and then Onyx Point as the vendor to support some of the changes. We needed a central kind of distribution point, so we decided to have a DOE centralized GitLab that we have OSTI hosting for us. And then at the facilities, there's a lot of changes and processes that needed to be changed at the facility because there's information that needs to go back and forth. There's polling. There's actually repositories at the facilities. Machines are at the facilities. There's different security enclaves that need to be worked through or not worked through. But ultimately, you want to be able to pull from a repository, whether you have it on a GitLab or GitHub, Bitbucket, or whatever, where project teams mostly are at, be able to transport it through OSTI and then be able to distribute your tests across different machines or different facilities. And then even at that point, once you get down to where the facilities have, there's a whole host of different machines that we're trying to configure as far as what is the need of continuous integration. So that's the vision, and it's still fairly much in play right now. Todd had this slide up, but it really starts kind of identifying where the difficulty is and where the issues are in actually being able to get from outside to inside. And we've kind of rolled in the whole idea of that you have to have some type of authentication process, which I'll go into a little bit later, to be able to get from having something outside to be able to run a machine that's sitting at one of the facilities. And the key capabilities that were integrated by Onyx Point, which were key parts of the requirements that we pulled from the facilities, were the whole idea of having set UID, so you know who you are as you run through the systems and can be audited in that factor. And then also the batch runner, mainly the batch executor, because all the facilities basically run jobs through batch submission. Now, right now, if you look at the key machines that are coming on, LSF with IBM is one of them. You've got Slurm as one that's been around for a long time, and then Cobalt at Argonne is the other one that we're addressing right now. Again, that has all been somewhat difficult to integrate because this is not something that is normally built into CI systems. CI systems usually run on a node. You have total control of everything you've got. But when you come to environments like we have, quite a bit more difficult. So if you look at a lot of the problems we're running into that we're having to solve is how do you actually get this ecosystem to actually work so you have a process that where you can authenticate users, you can actually register runners, you have some kind of validation all the way through the whole process. So we put this is our sort of architecture diagram. The issue that we're really having is when you get that, how do you authenticate? Because each of the sites are going to say, well, you're not going to run on my site just because you want to. You need to be able to have an account here. You have to have a process for authenticating it. You've got to have a valid token that you will come back and say, yep, you can run here and we'll be able to send your results back. And you have to be vetted for some of the machines that you're running on. So we're actually right now at the point of running through that last milestone 4 of the contract we have with Onyx Point. And we've been testing for a month, and we keep turning over problems that need to be solved. So we're working through that process. Hopefully, in the next month or so, we'll be able to get to the process where we can actually work it through. And then also, if you look at the sites, the one thing at the different labs is they all have different types of security processes. It's not one size fit all, even though I think that problem's been attempted to be solved many times in the past. But every site has their own way of handling their HPC accounts. They may have their accounts in a separate database and a different LDAP. When you try to figure out how well the users have been vetted or the type of authentication or authorization link you have, they're all a little bit different. So we're having to work through that. Obviously, if you look at across the key labs that we're looking at, you have different processes. You got Shibboleth at NERSC. At the NNSA labs, we're looking at one idea as a possible process, and then OLCF and Oak Ridge and Argonne are really going to set up different OAuth endpoints to do this whole process. So what is the planned model once we've kind of evolved to this point? And this is a different variation of the picture that you just saw. But for instance, right now we're doing a lot of we don't have the OSTI part working, but we are kind of working on this section where we are kind of prototyping, mirroring repositories into internal Git labs at the facilities. Then you're under their security envelope, and you can basically kind of run under their security rules. And we're kind of honing that out. The next thing we're doing, and we're doing that right now, is at NMC, we've got a couple of test machines at P9. So we're using that as a non-DOE test site to see how that would work. We have a couple P9s there that we're working on. And we're trying that process of mirroring through OSTI and having runners down at the NMC sites and working it that way. So in general, but the other thing that's kind of evolving too is depending on the security rules that come into what machines are available from OSTI, and there are some, that you may see that model where you actually may mirror your repository again down to an internal Git lab, and then you belong to internal rules at the laboratory. And then they may have many more machines available within their facility umbrella that you can kind of run on. So there's various evolutions of models that may come out of this. Now the testing tiers, where are we targeting? And so we kind of put this chart together just to get an idea of where people are and where we're trying to get to. So obviously tier 0 is what the sites are doing now, what the actual projects are doing now. And there's a variety of different things. Some are using continuous integration full bore. I mean, they've got Travis, they're doing stuff on the internet, they've got multiple ways of doing things. Others are still maybe using regression testing and maybe have very elaborate regression testing approaches where they're testing across multiple machines at different sites, but they've had to homegrown all that stuff over time. So there's a lot of different things, and that's not necessarily going to go away. What we would like to provide initially is this, what we're calling Tier 1, which is really a small set of nodes, but ability to get to at different sites. So you can actually test on architectures, maybe a limited amount of time, but have build capabilities and smoke tests, run tests to do that, and not necessarily need an allocation for projects to do that. When you get to Tier 2 and Tier 3, then you're really kind of working within what facilities want to provide to potential CI users. Some of those may be these test machines from early access from some of the large machines that they're going to get that might be in special enclaves. And Tier 3 is really when you're able to kind of throw a CI job into a production machine. But in that case, you do need to have an allocation. So if you've got time allocated, you're chipping away at your time. So if you're running scale tests as a CI and you're in Tier 3 and you're allowed to get in there, you're kind of working as based on what your checkbook looks like. Just a little overview of some of the projects we're working on and some of the sites. And as I mentioned, we've got internal stuff going on. This is the prototyping into internal Git labs at the facilities. We're working with a lot of different project teams, both ST and ECP AD projects at the different sites. And then this is where we're actually trying to test out with the Onyx point, where we ultimately want to go, but we need the authentication pieces to be working on for that to happen. Now going back to the whole software technology and how are we attacking this from a larger ecosystem? The question is, what are the priority products in ECP that need to be focused on? And we did a survey early on, basically looking at the applications targeted at some of the facilities. And the way ECP has done it is the sequence of exascale machines that are coming on. There's Aurora at Argonne, then Frontier at Oak Ridge. But there's also applications that are targeted to run on those machines. So we did a survey of application teams and what they require from their software technology components, and basically this is somewhat of a graph of what we're finding. Now, so this one just shows all together. These are if you look at this column, this is ST products, like OpenMP, MPI, MPitch, Sundales, Adios, things like that. But then if you specifically look at, well, what's targeted for the Argonne machine, the list comes out a little bit differently. And what this tells us is there's a certain priority as far as making sure that many of these teams that come up on the top really should be attacked for, make sure that they're facilitated as far as getting into the continuous integration and deployment of a lot of those products as well, so that there's smooth deployment and testing of all those things. So that's a little bit of how we're looking at it from the software ecosystem. So getting a little bit more to the nuts and bolts of actual deployment at the facilities, this is where, when Todd talked about this ecosystem all coming together, this is where a lot of the pieces start falling together, whether they're parts of the containers, part of the SDK, the E4S, this continuous integration. It all somewhat rolls together. So you see that it isn't all that different from what we had from the CI piece, and mainly because a lot of the software deployment uses a lot of the components that are coming out of what we're doing with GitLab CI. We're using that whole mechanism to drive build farms, to drive deployments, things like that. But what comes into play right now is, well, what are the facilities going to do with that? So obviously you've got SDKs and E4S coming from the ST project side. And so what are the SDKs and the E4Ss? They come down to recipes that are either integrated and tested or not. So when you get to the facilities and they're deploying software, they can say, well, I can take this SDK set of recipes. I know they've been vetted together. The releases all kind of tie together. So when I take that SDK, I can either take parts of that SDK or the whole SDK and say, deploy all these recipes, throw them into my build farm with this architecture, these combinations of MPIs and compilers, and what spits out should be binaries that could be used across, whether they feed into modules that fall under the different systems, or application teams can take advantage of that and build slight variations and put them in containers or something like that. So you can see where all this stuff slowly ties together. So what does it kind of look at? You're looking at SPAC, you're looking at SDKs, build recipes, the tool chains that the actual facilities need, because they sometimes are taking care of the machines in a slightly different manner. And then ultimately what the application teams can do with all that infrastructure, where they use facility deploy, or they take variations of their own, and they have their own little build processes to put that together. So obviously, I'm not going to run into SPAC, and I had some other slides that Todd basically went over, but obviously SPAC is a lot of the glue that holds a lot of these pieces together. So if you kind of step back and look at this whole ecosystem, you've got the GitLab CI components and the SPAC components that are key tools in this whole process. So obviously SPAC will be one of the key ones. And I think Todd had a better picture of this, but if you kind of look at where things are going across the play, you can kind of see how things are starting to glue together to put pipelines together. When you look at the facility pipeline that we're talking about here, this is really a variation of the SPAC build pipeline that the SPAC team originally had to kind of build SPAC packages. And when we looked at it, we said, well, that could be taken, put inside the house, put into a facility if they wanted to. And in many cases, with some of our facilities, they have secure environments. You can't just link up to the internet, and you may not want to. You may actually want all your products and all your binaries to be within the house to a certain degree. So we've been able to kind of migrate that and have a internal to facility build pipeline and SPAC stacks that are tied to a facility deployment. So ultimately, this is really what we're trying to drive towards. So key infrastructure all the way across the board, pulling all these things together, being able to pull in the cloud services and ability to share binaries if you want or not, or share up, continuous integration, and then really kind of put things together in a process that allows you for an ecosystem that you can actually use to deploy stuff and manage your deployment. And generally, it should get to the point where with the vetting and the testing, when you bring down products, the hope is that not only are they easy to build and easy to integrate, but they will work well together because of the ecosystem that's putting all this stuff together. So pretty much that's all I had. Any questions? General question for everybody: who is using CI right now at some of your sites or projects? Any? You guys are. I know you guys are. You guys better be. Okay. Yeah, it's been interesting to kind of watch the CI process grow. And I've seen, even as we work with different teams that are not using it, they may be doing different types of testing. And once they kind of understand a little bit about how this whole process is, they really start to gravitate towards it if you have the ecosystem to work on it. The way they put the YAML files together to be able to, that's one of the actual challenges that we're running into, because in many cases right now, when you're putting, you're testing on 1 or 2 cycles, but when you're trying to put something together that tests across 5 different architectures with 3 different types of builds, it becomes a little bit of a challenge to try to do that automatically so it works well. Okay, Samir, anything else? Okay.
Looks good. And take a break.